Hi, welcome to the tutorial on using character arrays, also called C-strings. Character arrays are what C programmers used to use to hold their text. Consequently, that's why they're called C-strings, okay, because they didn't have the string class to use. It's basically a one-dimensional array of characters, which includes at the very end something called a null character or a null terminator. The null terminator is \0. I know it looks like two characters, but it's considered one. And you can see that it's a character because it has single quotes around it. And the null terminator tells the array when the text data is finished. The format for declaring a character array is basically the same as for any other array, except it's an array of chars. The PowerPoint reminds us that the char data type has 1 byte per element, so it's a very lightweight array. Let's see, I believe that integers are 4 bytes, floats are 4 bytes, and doubles are 8. But you should always remember to make your arrays big enough to include the null character. So let's look at array initialization. It's basically the same process as with other types of arrays that we usually put numbers in. However, we have to be cognizant of the null character. So if we initialize a C string, char line 15, with I love C++, one of my favorite strings, there are 11 characters in I love C++. So, and don't forget, a space is a character. So this is how the array looks. I love C++, and then you have 5 null characters at the end that are automatically put there when you initialize with the string. Very handy. Now, what does the null character do? It lets the C++ know where the end of data is located. Very frequently, the null character is placed automatically. You saw one good example. But it's important to remember that a lot of the functions that we use require this null character in order for your program to work correctly. Well, let's see what that means. Here we are declaring some strings differently. First, we make a string object. This text is in a string object. Okay. Then we make a character array called C++ love, saying I love C++. It's initialized, and we know that the remaining characters in the array are going to be null terminators. Now we declare a character array, and it has only spaces, nothing in it, and we're going to assign the characters individually into those spaces. We don't fill the array, but neither do we add a null terminator. Finally, we declare an array with no text and just leave it. So there's nothing in there. If we look at the where the data items are stored in memory, the no text has trash in it. The no null text has whoops, no null, and then trash. The C++ love has I love C++ and then null characters. And the string object just has a string object in it. Now let's write all 4 of them. We're just going to see out all of our text, because here we have a string and these are C strings. Again, where are they in memory? Trash, null character, and a string. Cout writes until it sees the null character. So this is what happens. The string object writes perfectly. The C++ love object writes perfectly, and the no-null text writes whoops no-null. It writes the garbage characters to the end of its array, and then it writes I love C++ again because there's a null terminator at the end of I love C++. The no text array writes all trash, then writes whoops no null. It writes the trash at the end of the whoops no null array, and then finally writes I love C++. Isn't that a mess? When we try to write no null text, it writes characters until it sees a null character, same as with no text. It just basically keeps looking for the null character, and if there's never a null character, well, then you have a real serious problem. When you see this kind of trash character in your output, then you are writing a character array that does not have a null character at the end, and you need to go fix it. It's a dead giveaway. Okay, how do we input to character arrays? Well, a character array is text, so we're going to use a getLine. But it's a different form of getLine. This one says cn.getLine char star text int max. Well, what the heck is this char star? Well, remember, it's a character array. So this is the pointer to the character array, and text is the name of your array. The getLine function reads until it sees an enter key, or if it has read max -1 characters into the array. So if you have an array of 50 and it says enter your full name, depending on how long your name is, the whole name will be read into the cn.getLine. There are a couple of really good functions that we use, and these are functions, again, from C because they work on C strings. As you know, sometimes when we use a CN to read numerical data, if someone accidentally puts a character instead, we fail the data stream and we get an infinite loop where CN keeps looking for the data type that it was expecting. So an alternative for reading numeric and character data is to use a getLine and then convert it to a number. So if you read anything, okay, into a C string called buffer, then you can use a function called a2i, and it will return an integer that is represented in that buffer. If it's a floating point, then you can use a to f, and that will give you either a double or a float. Both are in the C++ standard namespace. Whoops, I'm going backwards. There we go. I have a couple more things to say about this. You need to be a little bit careful because if your C string does not contain a number, okay, say it contains your name, then a to I can't convert it to a number, and neither can a to f, and it will return 0. It doesn't break, it just returns 0 to say that it couldn't read a number. So if you are expecting the number 0 as part of your data, you have to be careful of that. Okay, character array functions. Well, since C programmers used character arrays a lot, I mean, they needed to use text as much as we do, then they have functions for working with character arrays. They do copy, concatenation, comparison, searching, etc. And the prototypes show character pointers as the input. And we've already discussed that is the character array name. So here's an example of some of those functions. StringCat concatenates two character arrays. The first one is called dest, the second one src, and so it concatenates src with dest. You use the function this way. And since the character array is an array, then you pass S1 and S2 the name of the arrays. They work just like regular arrays, except for the null terminator and that we're dealing with characters. String copy copies the src into dest. String comparison compares S1 and S2. Returns 0 if they're the same. Less than 0 is if S1 is less than S2. Oh dear, this should be S2. Typo. And greater than 0 if S1 is greater than S2. We passed in two separate names. These should be differentiated also. Then we have a string function where we return a pointer to the first occurrence of S2 in S1. So what does this do? This is like the find function in C++ string objects, where we are searching for the character or a string from S2 in S1. This is a continuation of that description. Then we have the length of the string. That's handy to have. And that returns the length not including the terminating null, which is very nice. So this is 11 for I love C++. And then we can copy the string. Copies the characters from the source to the destination. And depending on how many, I can't remember what the N stands for, we would have to look it up. It either means where to start the copy or how many characters to copy, and I don't use these often enough to know off the top of my head. It looks like we're not going to get into multi-dimensional arrays. This topic is discussed in detail in your book. You will not need it for any of your programs this semester. We may use it in C++ too if I see you there. Okay, that's it for C strings and A to I and A to F. If you have any questions, feel free to email me, come to office hours, or put a question on the discussion board. Bye.